Hello guys, welcome back to Maison African Motifs, still on mathematics and two revisions. In this case, we are going to be focusing on trigonometry, whereby we are given typical questions from past exam papers. I'm having the question paper from November 2016 that we are going to focus on, where we are given. So I'm just gonna indicate this part so that we can see properly. So we are given on 5.1 to consider fig 2 below, where we are given that AD, a cliff, a vertical cliff. So we are given that AD is representing a vertical cliff. Then and is 65.8 meters high. B and C are two boards in the same horizontal plane. So this part here, B and C, these are the boards that we are given, B here and C. Then we are given as the foot on the cliff, okay? The angle of elevation from C to D, that is y degrees. So remember the elevation, when you are referring to the angle of elevation, that is the angle that you are using to consider a certain point. Let's say we are having a horizontal view. You are on a horizontal view normally. So you want to look on top of a certain pole. Maybe it's a vertical pole or it's a building, whatever that you are referring to. So the angle that you are using, this part, this angle that is in between, let's say this is your horizontal view, where you are having your eyes in line to the horizontal line. Then the top of the building or the top of the pole, that is at this point. So this is a vertical line. So the angle of elevation is simply this angle that is in between, that is the horizontal point of view and to the top of the pole or to the top of the building or whatever vertical part that you'll be given. So this is simply referring to this point C, where we're given the angle of y, looking at the top of the cliff. We are given that AD, it's a vertical cliff. So that is the idea of what the angle of elevation. So it's nothing to consider much about, because everything we refer back to our trigonometrical ratios. Okay, so this is the diagram that you're given. Let's check the questions. The first part of the question, which is on 5.11. All right, so this is what we have here. Calculate the length of the side BD, and that's 3 marks for that. Okay, so we want to calculate the length of the side DB. Okay, so that's DB in this case. So D to B, that is from this point up to this point. This is your DB. So if you are to consider this part, if you are to check properly, this triangle, let's say 5.11, from triangle ABD, this triangle here is a right-angled triangle. So meaning we can apply our Pythagoras theorem to calculate the third side, since we are given two sides in triangle ABD. Okay, so using triangle ABD, which is a right-angled triangle. So we can apply our Pythagoras theorem, which states that the hypotenuse squared is equal to the sum of the squares of the shorter side, the sum of the square of the two shorter sides. So that is the hypotenuse, is the side that we have to calculate, which is DB in this case. So it means DB squared is equal to the shorter sides, that is AD and AB. These are the shorter sides of your right-angled triangle, okay? So you apply this on a right-angled triangle. There's a 90 degrees here. So you're going to have 49.7 squared plus, you take any, you can start with this one or you can start with that one. It's not a matter of fact, this one. All right, so this is the formula that we are going to have to calculate a DB. So in this case, as we can see, the DB is affected by the square. So to remove this square, we are going to introduce the square root both sides. The moment we introduce the square root, we are removing the square that we are given here. So it means DB is going to give us the square root of everything that is here, which is the square root of 49.7 squared plus 65.8 squared. So the square root of everything here is going to give us DB or BD. All right, so if you have to simplify properly from your calculator, you're going to obtain 82,46047 and so on. So if we are to round off to 3 decimal places as per given instruction, we are going to have 82, that's 1, 2, 3. So this is going to be 460. The 4 cannot change this 0, so it's going to be a 0 like that. This is in meters. So take note of the units that you're given. The other sides, they are given in meters. So it means this side is also in meters. So that's how you can check the units. You refer to the other sides that you're given before. All right, let's check the other part of the question, which is on 5.12. We are now given to calculate the length, the magnitude of the angle y. Okay, the magnitude of angle y. So let's check what we are given on our diagram. Where are we having the angle y? So this is where we have our angle y in this case here. All right. Take note of this diagram that we are given. If you are to consider this whole triangle here, we want to calculate this angle here. If you are to consider this whole part of the diagram, the whole triangle, that's 5.12. If you are to consider this triangle, I want you to see something from point C to point D and to point A. If you are to consider this part only, all right, we have got C at this point here. We want C to D to A. If you are to consider this triangle, not we have in this part, yes, we know that we are going to have this BD or whatever, B to D, this part across, but we are not considering this part. I want you to see that we are given 104 meters from C to D. We are given 104 meters. From A to D, we are given 65.8 meters. With this triangle, considering this whole triangle, you're going to see that the angle y that we need to calculate here can be actually calculated from these two sides. Once you are referring in a right angle triangle, you can name these sides according to the angle of y. So which means we can name this side according to this angle. This is the opposite. It faces the angle y. They are opposite to each other. The hypotenuse is always opposite to the 90 degrees. This is our 90 degrees. So this is your hypotenuse. So what you're going to do is to ask yourself, which ratio am I going to use? Which uses the opposite and the hypotenuse at the same time? There's only one ratio from our SOHCAHTOA mnemonics. So from these mnemonics, we check which ratio he has got opposite and hypotenuse at the same time. That is for sine, opposite, hypotenuse. So we can write our ratio down. The sine of theta should give us opposite over hypotenuse. So we can substitute our information, that is the sine of theta representing the angle that we are given, which is y. So the sine of y degrees is equal to the opposite, our opposite in this case, that's 65.8 over the hypotenuse in this case, which is 104. With this information, we can calculate the value of y. So how can we calculate y? So remember that y from a trig of sine is going to be written as arc sine or shift sign from your calculator. That's shift sign. You represent exactly as it is on your calculator. That's what you're supposed to obtain. Or this presentation as it is. So if you have to determine the arc sine of this, we are going to obtain 39,24903 and so forth. So y is equivalent to 39,123 to 3 decimal places. That's 49 degrees. 0 cannot change 9. It's less than 5. So these are the typical questions on how you calculate. So sometimes they might not even ask this y, but you might be asked a question which needs you to apply this angle y, or where y is involved in your calculation and you are forced to calculate that y. So it can be like that, but this question was direct that you're supposed to calculate y. So that is the idea. Then the last part on this triangle was to calculate the length of the side BC. All right, so you need to calculate the length of the side BC. That is from B to C, this part here, from B to C. So this is the side that we are supposed to calculate. Okay, I want you to check something here. If we are given, or if we had this side from A to C, and also, guys, there are so many ways that you can apply, or so many formulas. So if you've got another method, please just mention on the comment section on what you've done. Say, maybe I could have used this method. It can actually work. Then if we are going to have another time, we are going to focus more on other methods so that we can have different ways of answering these questions. Okay. So what I'm trying to say is, if we were given this side A to C, let's say we have this AC. Can we not determine BC? We can, because AC contains BC, or BC is in AC. So if AC contains BC, it means we can have this value for BC, because the AC as it is, it consists of A and B, A to B, plus from B to C. So as we can see, if the whole of AC consists of AB and BC, therefore we can just make the part that we have to calculate, which is BC, the subject. So that is our BC. We can transpose AB to the other side, which means this is going to be AC minus AB. This is going to give us BC. So BC is going to be determined from AC minus AB, whereby we do not have AC. If you have to check from the diagram, from A to C, we do not have this side. A, B, we have it from the diagram. We have A, B, this part. So meaning we are to calculate the side A to C. A to C, how can we calculate A to C? We can use any concept. You can use trigonometrical ratios, having the angle Y. You can use opposite over adjacent. You can use adjacent of whatever ratio, or you can even use Pythagoras theorem. I want you to check properly here. We want to calculate AC. From A to C here, we can have it from the diagram. So we've got two sides. Easier to apply Pythagoras theorem to calculate AC, because we know that from our Pythagoras theorem, all right, let me just write, this is 5.13. All right, so that's 5.13. So we know that from our Pythagoras theorem, we wrote this formula before: h squared is equal to a squared plus b squared, which means the hypotenuse is the what? The side opposite to the 90 in this case, which is the 104. So this is 104. So we're going to have this as 104 squared is equal to, then the other sides, we are referring now to the side AD, which is this side AD and AC, of which AD is 65,8. So this is going to be 65,8 squared plus the part that is left, which is AC. So we are going to have AC squared. So from there, we can calculate AC just like the previous part, or when we applied our Pythagoras theorem. So this is going to be 104 squared. We can transpose 65,8 squared, which is going to be a negative, is equal to AC squared. So to determine AC, introduce the square root both sides. So AC is going to be the square root of everything in this case, which is going to be 80, 538 in meters. So that's our AC. So remember, the purpose of calculating AC is because we need this value to obtain BC. So we can substitute now the value of AC into the formula, because already we have made this the subject. Remember, this is our BC, guys, from B to C. So if we remove this 49,7 from AC, we remain with C. That is the idea. So which means we can substitute our values now to calculate BC. So therefore our BC is going to be AC, which is 80,538 minus AB. AB is the one that we are given as 49,7 in meters. So this is going to give us BC in meters. That is 30,000 838 in meters. So that is the idea of the question. So these are the typical questions. Like I was saying, guys, you have to be very, very careful when attempting these questions. All right, on 5.2, we are now given the last part of the question where we are given that if sine of theta is equivalent or is equal to m and theta is less than or equal to 90 degrees. Actually, this question was not properly given, because if you are given that theta is less than or equal to 90 degrees, there are infinite values which are going to be referred, because we are referring to any angle that is less than or equal to 90, which means also minus 180 degrees is less than this, minus 360 is less than 90. So this question was not properly given the interval. We are supposed to at least be given that our theta is supposed to be in the interval from what? From 0 to 90 degrees. Or they can give us as theta ranging in a way that our theta is greater than or equal to 0 degrees, but less than or equal to 90, so that we actually know that, yes, it's less than or equal to 90, but limited to 0. If we are not given the lower limit, it means we are having so many intervals that we are going to be focusing with. Okay. Anyways, so how do we attempt such typical questions? What you need, this is actually for the quadrant. That's why I'm focusing on this much, because it gives us the quadrant where we are going to have our sine of theta, which is equal to m. It gives us the quadrant. So if this is from 0 to 90, which means we're referring to the first quadrant. Remember, in the first quadrant, all right, let me just try to reduce this font a little bit. All right, so in the first quadrant, we know that we are referring to the angles that are being taken from what? From 0 degrees to 90, any angle in between. That's the first quadrant. So we are given the ratio of sine of theta, where we know that sine of theta from our SOHCAHTOA, we talked about this one, SOHCAHTOA, we said the sine is opposite over the hypotenuse, so which means we are given the sine of theta as opposite. Here we are given this as sine of theta is equal to m. So we are supposed to have it as a fraction. Why? Because in this quadrant, we are going to have a triangle that is going to represent this ratio. So if we are having a triangle, we need the opposite and the hypotenuse from the theta that we are having. This is your opposite, this is your hypotenuse. So what is the value that is going to represent the hypotenuse? It is going to be 1. Why? Because m over 1 gives us m. It's same as m, just like 2 over 1 is 2. 3 over 1 is 3. So m over 1 is same as m. We haven't changed anything. What we are trying to do is to just rewrite this as a fraction so that we can properly see our opposite and we can properly see our hypotenuse. So the opposite is m. So which means this side, that's our opposite, which is m. The hypotenuse is 1. So this is your hypotenuse, which is a 1. So the question is to determine the tan of theta or theta. So these other ratios, they need us to involve even the other side. According to theta, we say this is your opposite, this is your hypotenuse. We also need to determine the adjacent side because it's needed in the other trig. So how are you going to determine the other side, which is the third side? We can apply back our Pythagoras theorem. Remember, we talked about the Pythagoras theorem to say that the hypotenuse squared is equal to a squared plus b squared. So you can write this as x squared plus y squared, where the hypotenuse is 1. So 1 squared is equal to a squared, which is m squared, plus the side that we want to calculate, which is the adjacent. So we can even write this as x or whatever that you want squared. We want to calculate the value of x, so we can transpose m squared to the other side. Remember that 1 squared is 1, so it is going to be minus m squared, which is equal to x squared. So to determine x, this is squared. So we remove the square by introducing the square root both sides. So this is going to give us x. So x is equal to the square root of 1 minus m squared. So this part here which is representing our adjacent, can be represented as the square root of 1 minus m squared. So this is the square root of 1 minus m squared. So we have completed the diagram according to the ratio of sign that we're given. This is going to help us to determine whatever ratio that we are given, tan theta. So we are now back to these mnemonics that we talked about. So in this case, to determine the tan of theta, so that's 5.21, 5.21. So the tan of theta is going to be what? Remember, from Torah here, tan opposite over adjacent. So the tan of theta is supposed to be opposite over adjacent. So that means the tan of theta is equal to the opposite, which is m. So we are going to have m over the adjacent, the one that we calculated now. You see, it's involved in your calculation, which is the square root of 1 minus m squared. So you have the ratio for tan of theta. We move on to the other question, which is 5.22. We are now given to calculate the cos, the sine squared plus the cos squared of theta. All right, so we are going to have the sine squared of theta plus the cos squared of theta. Okay, if you are given a squared like this, it is the same as sine theta squared like this plus cos theta squared like this. It's the same. So the sine of theta, we are saying to the sine of theta, we are already given, this is the one that you are given, or you can use the diagram, but we are already given that the sine of theta is equal to m. So we can substitute our value for sine of theta, which is m. So this is going to be m squared plus the cos of theta. We do not have this value, so we're going to calculate it from the ratio cos of theta, that's adjacent over hypotenuse. So if the cos of theta is adjacent over hypotenuse, we are going to have adjacent, which is this side. This is our adjacent, the square root of 1 minus m squared over the hypotenuse, which is 1. Like I was saying here, 2 divided by 1 is same as 2. 3 divided by 1 is same as 3. So if we divide the square root of 1 minus m squared by 1, we are going to obtain the square root of 1 minus m squared, just like 3, 3, 2, 2. So it's the same thing also. So which means the cos of theta is equivalent to the square root of 1 minus m squared. So here we are going to substitute the square root of 1 minus m squared, everything to the exponent or to the power of what? 2. All right, so let's see what you're going to have in this case. So if you are to simplify, m squared in a bracket, this 2 is going to affect 1. 1 times 2, which is 2, so it's m squared plus a square root when raised to the power of 2 or to the exponent of 2. We are simply removing or neutralizing this because it's the same as to the exponent of half to the exponent of 2. Square root to the exponent of a half. Then we are given to the exponent of 2. So this cancels, we remain with exponent of 1. So this is going to remain as 1 minus m squared. So take note here, we are going to have plus 1 minus m squared. Since this is a plus, there is no need for us to have the brackets because if you are affected by a plus, we are going to just remain with this plus times 1, which is plus 1 times minus m squared, that's minus m squared. So if you expand, we can now collect our like terms, that is m squared minus m squared. This is cancel because this is same as 1 minus 1. Okay, so that means we are going to remain with a 1. So that is the answer. So this is actually one of the identities that you're supposed to actually know, to say that the sine of theta or the cos squared of theta plus the sine of squared theta is identical to 1. Or it can be written anyway, the cos squared of x plus the sine squared of x is equal to 1. This part we are supposed to actually know it as one of our identities that we are supposed to work with. Even as we go on to our mathematics N3, we shall have this identity a lot of times. So you're supposed to actually know it. Here it was like proving that identity. Okay, so that's it, guys, from Meson African Motives, working on mathematics N2. Let's continue to work with more questions, revision as we revise and prepare for exams which are ahead of time. For now, that's it till we meet again.